Hi, Emma. We'll wait for everybody to do final review, okay? Hi, everyone. How are you doing? We'll start final review part 2 continuation shortly, okay? Hi, everyone. We'll start shortly. We'll wait a few more minutes for more people to join and we'll start final review part 2 continue. Hi, Sarah, Sue, Scott. How's everybody doing? Good? Here comes Jason now. Barbara. Good. So we will pick up where we left off for final review part 2, and then I'll stick around for questions when we finish if we have time. Good, thank you. And that will wrap up the last meeting that I will have with you. Don't forget that your project is going to be due soon, so make sure that you work on that. I'm available for questions in case you have questions on Wednesday evening. I'll sign on to Zoom. So if you're stuck on something or if you have questions, you can come. Yep, that will be fine. If it's locked, let me know which one. I'll unlock it for you. Okay. Some of the earlier ones are closed, but yeah, let me know which one. I'll unlock it for you. So there is another extra credit assignment at the end during the final week, which is your course survey that I do for every class. If I will post that during the final week or next week, but there will not be any kind of lecture after this. So if you have questions, you can sign on Wednesday. We can talk about your questions during the class time, or you can see me during office hours. And then that way you'll be prepared. Okay. Okay, 6 o'clock. So just a reminder, final exam. 1 second, let me get back to my dashboard. I was in the message. Final exam is going to be open on the 7th, and you have until the 9th to finish for this class. So it gives you a couple of days. Okay. And then I started grading the project sign up part. So if you haven't done that, I will check back on my Google document. But if you haven't done that, make sure you do that so I can update your grade. And then make sure that we're working on part 2 and part 3. If you're working in groups, you can. If you're working by yourself, make sure that you get your tasks completed. In any case, make sure that we turn in our project, even if there's something still missing, or at least you'll get some partial credit with that. Okay, but I like to have completed projects submitted if possible. If not, make sure that you turn in what you have. Okay, and final exam will be closed on the 9th, so make sure that we set up some time to do that. I will give you 2 tries for it, but we will use lockdown browser. Okay, so don't forget. Okay. So we left off in part 2 for final review at question 13. I highlighted in green so I remember. And a lot of these questions you saw in your assignments already. So we wrapped up last time with geometric sum, where we were given the first 4 terms. And so you need to apply the geometric progression equation, which is this one. Okay. And then with that, we would use the common ratio for the R, and then the N is the term, and we plug everything in based on the numbers that are given. A is the 10, that's the first value. And so we would then put in the equation, and R is 3. As you notice, it's multiplied by 3 to get the subsequent term. And then we wanted to get for the first 4 term, so we would then take the n plus 1. And so you can solve for this by plugging into your calculator. Then for question 13, we define recurrence. Make sure that we know the definition for recurrence. And we dedicated a chapter on, or we went over a session on recurrence and how to apply that to our equation. So it's a way that we look at the relationship that would recursively define the sequence. So that way the next term is a function of the previous term. And we did a lab on Fibonacci, looking at the sequence, Fibonacci sequence, and how to iterate through it. You can implement recurrence in that case if you're working with sequence like Fibonacci. So you would see a question on the test that would ask for the definition of recurrence, it might ask you to pick the appropriate option that fit the definition, or it might ask you to fill in the blank, which is going to be the actual term itself based on the definition that's given. Okay. Any question with 13? All right. So for 14, we did this in our assignment. So we want to find the recurrence relation with the initial conditions. So it gives you a sequence 1, 5, 17, 53, 161, and 485. And so we know that recurrence relation based on number 13, it would allow us to calculate the future term based on the previous term. So if we start with 1, we can build that from there, and we wanted to look at the relationship from the first term going into the second term. So the process in this is you would first find the difference between the terms arithmetically. So if we take 5 subtract 1, we would get a 4. 17 subtract 5, we would get a 12. 53 subtract 17, we would get a 36. 161 subtract 53, we would get a 108. And 485 subtract 161, we would have 324. We can stop there as this is what's given to us. So when we look at the difference outcome after we did the subtraction between the terms, we would then determine the progression in the difference. So when we look at 4, 12, 36, 108, and 324, we ask ourselves, is there a common factor or is there a common ratio? So going from 4 to 12, we know that 4 times 3 is going to give us 12. And then from 12 to 36, we would then multiply it by the same common ratio, which is 3, and so on. So we see that the common factor in the difference progression is 3. Then from there, we would then take the difference and we evaluate it. We come up with the common ratio. Then we would go back to our arithmetic progression, which is in chapter 11. I put a note for that for you there. And we would use the equation to evaluate the difference in the arithmetic progression. So then we would then take that and put it into the equation. We would have a of n is equal to 3 times n minus 1. N minus 1 indicated that it's the previous term, plus 2. Okay. Now, I'm not going to require you to do the n plus 1 on this one, as long as you can come up with how we would be able to determine the term based on the previous term. I'm fine with that. Okay. So why is it 3? Well, 3 is because we have 3 as the common ratio here. And so we will plug that in there. And then because we would take that 3, multiply it by the previous term, plus the 2, that's going to give us the next. So we can check that, right? 3 times 1 plus 2 gives us 5, which is the second term. And so on. So you can check it for every term if you want to make sure. Okay. So if you see something like this on the test, it asks you for the recurrence relation. It will give you the options on how the equation would be. And you have to pick the right equation to express, right, the relationship from one term to another, the recurrence relation for this sequence. Okay. Now you don't have to write everything down for the final review when you submit it. The final review is designed for you to look at the material and jog your memory and write down the notes so that way it will help you study for the test. So the way I had it written here is detailed, but you can summarize it if you want, or you can write down how you would calculate it. That will be fine. Any question with 14? Okay. I see a chat question. Okay, good. Just a comment. All right. So this came from chapter 11. So if you want practice, make sure you go back to the notes and the assignments. And I pulled that, if you recall, that's from your Unit 9 assignment. Okay, that's question 5 from Unit 9 and question 4. So all of these questions should look very familiar to us already. So you're going to see something similar to this. Next, we're going to touch on Fibonacci. And we did a lab on Fibonacci in this class in C++. So for Fibonacci, it asks you to describe Fibonacci sequence. And so for the sequence function, for Fibonacci numbers, it's defined as a occurrence relation, the equation that recursively defines the sequence of multidimensional arrays. So once one or more initial terms are given. So in Fibonacci, recall that we have to seed. And in the common approach, you would start with 1 and 1 as the first two terms. You have to have the first two in order to calculate the next one. Okay? Because for Fibonacci function, it would take f of n minus 1 plus f of n minus 2. So the prior term and the term before the prior term, so two terms in from the current term. And yes, you can seed with 0 and 1, right? But in most common program that you see for Fibonacci, we would start with 1 and 1. And in that, if you use the iteration approach, you would then have to implement the if statement, right? If it's equal to 1, if n is equal to 1, then we're going to return 1, right? And then after that, you can nest that into the for loop. We did a few programs, for example. So in description, what I care about is you understand the relationship across the terms for Fibonacci numbers. So its function is f of n is equal to f of n minus 1 plus f of n minus 2. And you can seed it at 0 and 1 or 1 and 1. And so if we seed it at 0 and 1, 0 plus 1 gives us 1, 1 plus 1 gives us 2, 1 plus 2 gives us 3, 2 plus 3 gives us 5, and so on. So you would add the last two numbers to get to the next. Okay. Any question with Fibonacci sequence? And you often see professors use these type of sequence to ask you to write program for exercises, right? You can do it in Java, you can do it in C++, Python, and so on. So just implementing the algorithm for Fibonacci. There are several ways that you can approach it. We looked at some techniques and so how we would approach the program. And you can also write it, recursively, right? You can have a function that calls itself. So you can have like int fib and then define the function, and then in the main you just, or when you do the function call, it calls itself. You can return from that. And then in the main you can declare your seed values. Okay. So fairly easy program to do. Let me move this up a little bit. So for the test, we also need to know how to read graphs. And in this class, we dedicate 1 week looking at non-weighted graph or simple graph, and then weighted graph. And some of you are working on this for your project. And graphs is so important across the board for computer science. It's a way that we can visualize data, especially if you're looking at communication system, like I gave you some example. It also a way for us to visualize data, how data flow across the systems, and also use it for analytics or machine learning, and so on. So we are given a weighted graph, non-directional, and you would have the value on the next to the edge to indicate the weight. And weight could be varied from the aspect of priority, um, or it could just be how the cost of the path would be. Okay. And so if you're looking at a cloud environment, if you're looking at like infrastructure on the cloud, a lot of the times we would look at like virtual machines, instances, data storage, database, and so on. And we can assign the value across how the system communicate and pass the data, or data is being accessed. And we would assign the values to that. Okay. So there's not like 100% way, like an exact way to really assign these values. It's just going to be based on what the organization is considered. Could be critical, or it could be, the weight that's tied to the cost, or it could be priority. So we're given that, and we're asked to create adjacency matrix. So if you have it weighted, I use a table format, but you can definitely use the matrix. So then you cannot have a node that goes into itself. So it will be 0 for A here. And then from A to B, you just put down the weight to B, A to C. That will be, because they are adjacent, you put 3. If it's not adjacent, like in the case of A to D, it goes over, it has to pass over C, so we put 0. And then A to E, there's a 2, and so on. Okay, so we would build out this matrix, and I started some of it for you, and you can go through and you can fill the rest out. So then we would go to B. So each of the vertex needs to be evaluated for adjacency. And in C++, like I said, if you wanted to build that out, it's the way that you have it now, you have learned to implement graphical user interface with it. So you just build it out with, showing the matrix or showing the actual path, different type of paths in your program. You can implement libraries that are C-based to be able to graph things out, of course, like we talked about GraphViz. Okay. So build out the matrix and make sure we put the weight in for adjacency. Any question with 16? Okay, good. All right. On the next one, 17, it asks you to refer to the directed graph below. And we want to do a breadth first traversal starting with vertex F. And you can choose your destination, right? But I wanted to do a complete breadth first traversal starting with vertex F. So a way that we can do this is with the breadth first traversal, it's going to seek the adjacency from the starting point on both routes. So if we want to start with this path with F, E, B, C, D, F, and alternately it can go F, B, C, D, F. Okay. So you notice that here when I came back to F, I wanted to indicate B because when it sends, it's gonna start going from the E way, or it also see who is also adjacent to S, which is gonna give F, which is gonna give you a B. So for the breadth first traversal, right? Unlike your simple path, you can repeat the vertex. So it's going to go F, E, B because E and B are adjacent to it. Okay. So it's going to go this way and this way. And then from B, we can go C, D back to F. Or we can go F, E, B, C, D back to F. Now, because this is directional, it has to follow the way the arrow is pointed. Okay. So if I wanted to go F, E, I cannot go to G, A, B, C, D, F, right? Because the arrow is pointing a certain direction. So I have to follow the arrow. And any path is really easy, right? We just don't repeat the node. So we can just go F, B, and then you can do like C and D if we want to go from F to D. Okay. Or we can do from F, okay, this one we're going to say 2D. We say from F to, let's say C. We can say F, and then we go E, B, and C. So any path will just follow the arrow starting from your source vertex. It can also go from F to B and ends there, right? If we're just going to go to the adjacent vertex and stop there. So yeah, that happens too. Okay. Any questions on 17? So make sure we know how to read the graph and be able to establish or come up with path, right? Like breadth first search, and then depth first search. So and I just finished a couples of the lectures with my Python class the other day, and when we looked at this, when we looked at how cloud nodes are communicating and how data is searched in the instances, you see this being implemented on AWS or Azure. So it's applied across many different platforms. Okay. For C, demonstrate the shortest path from vertex A to F. So let's go back and take a look at A to F. So if we start from A here and we need to go to F, we have to follow the arrow, right? We can't just cut through and say, oh, A to B and go to F, because the arrow is pointing the other way for F. So we have to start with A, we need to go to B, and then follow the arrow C, D, and then F. So that means that we would have A, B, C, D, F. Now, if it's not directional, you can just find the least number of vertex that you would cross to give you the shortest path. But the shortest path is not always the cheapest path. So if it's weighted, you have to sum up that path and the lowest sum value for the path in comparison, then that will be the cheapest path. Okay. Then for D, it asks you to determine the cheapest path. And in our case, we don't have alternate solution because number one, it's not weighted, right? So you would treat all of the length for the connector is all going to be treated as one. And you have to follow the direction on this graph because it's the way the arrow is pointed. So in this case, our cheapest path is equal to our shortest path. Now, like I said, it's not always the same, right? Depending on the graph. So like if it's weighted, you have to determine the sum of the weight for your path. It has to be the lowest to be cheapest. Okay. So there's a few things that we need to consider when we look at the graph to determine cheapest and shortest is whether it's weighted, whether it's directional, right? And you have to follow the direction if it's directional, and then you consider the calculation for the weight if it's weighted. Okay. Any question with C and D for 17? All right, almost done with part 2, and you will be free from CIS7 as we completed all the lecture. Okay, 18 for part 2. Determine the cheapest path, shortest path, simple path for the below graph from node B to D. Okay. So this one is a weighted non-directional graph for number 18. And so we would then need to look at from B to D. So here's B and we need to go to D. So alternately we can say, okay, so the first one is going to be BACD. That's going to give me a total of 9, right? If I go BAED, that's going to give me a total of 12. So it would not be cheaper than the other one, right? If I go BAGFD, that will be much higher. I would have a total of 12 with 7 and 2. So 9 plus 12, that's 21. So that will be very high. So if you're looking at your options for the path from B to D, if you sum it up, and if it's the lowest, it's going to give us the cheapest. So that will be BACD. And that your total, the sum is going to be 9 for that path. Now, considering the shortest path, we would have to look at the number of vertex that we have to cross, like the adjacency in between. So if I go BACD, I only have to cross over A and C. So if I go BAGED, I have to cross over 3, so that won't be the shortest. Or if I go BAGFD, that's also over 3, so that won't be the shortest. Okay, so when you look at your path options, you have to know that the one with the least number of vertices will give you the shortest path. Okay, and that could be the same or different than the cheapest path. Keep in mind. Okay, and I use the same one for the simple path because I just need to get it from B to D. So the simple path, as long as you don't repeat the vertex, you would have a simple path. Okay. Any question with 18? Okay, so you're going to see something like this on the test, very close to it. It will ask you to look at the image of the graph, and then you have to select the option that represents cheapest path or shortest path or simple path and different type of path. Okay, so there are a few questions that relate to graph on the exam. And like I said, exam is multiple choice, so you just have to determine the right option for that question. Okay. Then in the unit 12, we touch on chapter 5 with encryption using substitution cipher, encoding, and we touch on what is that? Modulus arithmetic, because mod is often used for encryption program. So for 19, it asks you to explain or define substitution cipher. And so your plain text message that will be using letters or characters is then being replaced with another letter or character that is using a fixed number position down the alphabet. And Caesar cipher is a perfect example for this one. So if we're shifting it 3 places to the right, that will be the number of character that we're gonna use to down the alphabet to replace our original plain text character with. Okay, and you can use any value like 13, 7, 6, 3, and so on. And that you just have to substitute the character that is a certain number of shift down the alphabet or up the alphabet. So when we decrypt it, we have to shift it back. So if you shift right to encrypt, then you would shift left to decrypt. So that will be substitution cipher. And so for the question, we can solve it. Okay. For number 20, Helena uses Caesar cipher to encrypt the message discrete structure using the following formulas. What is the value of n if she encrypt the message as that? So it gives you the encrypted message. And we know that the original plain text is discrete structure. So if you start with the letter D here, and you know that it encrypts at K, right? So here's D and here's K for the first letter. We just count it 1, 2, 3, 4, 5, 6, and 7. Okay, we can test it again with the second letter I, and it shifted to P. So here is I, we count 1, 2, 3, 4, 5, 6, 7. So that means that we shift 7. So your end value is then 7. Okay. Okay, any question for 20? So you might see something like this. And when we're looking at the equation, right, it's going to take the character, which is x, it's going to do a shift. So it's going to add the shift value, which is now we determine that it's 7. And then mod 26 is because we have 26 letters in the English alphabet. So if we're using the same approach in other alphabets, then we would be able to change this depending on the alphabet total, right? So if you have like something that has 100 and something different characters, then you would have it mod 100 and something. Any question with 20? All right, pretty simple. So I put here, count the letters, and it's going to be 7. Or also you can see that here. For 21, we go over relation, and that's chapter 17. And so based on your given sets and subsets, we want to determine your domain and range. Okay, so we can say, what is the relation? So first, we're going to list the first value in the pair, which is your x for the domain. So I list 1, -2, 3, and 4. I don't list 1 twice because we don't need to list it multiple times, right? So there we go. And then for the range, I list the second value in the pair, which is y. So 3, 7, -3, 5, and -3. So I only list -3 one time, right? So 3, 7, -3, and 5. So we can say that it is the function of of x is to y, or we can say that it's 1 to 3 for the first one. This one, that would represent the first one. Any question? Okay. Then for 22, you saw this before in the last unit that we covered. Given the set 1, 2, 3, 4, decide whether it is reflexive, symmetric, anti-symmetric, or is it transitive? Right? We have 1, 1, 2, 2, 3, 3, 4, 4. That one's easy. It is reflexive. It is itself, right? I have a 1 and a 1, a 2 and a 2, a 3 and a 3, a 4 and a 4. You might see graph representation of these properties, of relation properties. So for 23, when you see a circle with the arrow to itself, that means that it is itself, so it's reflexive. And then for B, when it's symmetric, A is equal to B and B is equal to A, so that will be symmetric. And then for the third one, you have A is equal to B and B is equal to C and B is equal to C. So therefore we would say that A is equal to C. So that is transitive. Any question with number 23? So likely you will see these. And final exam is 50 questions. They are 4 points each. All right, 24, we need to solve using modular arithmetic. So for 24A, we have 23rd to the 3rd mod 9. So if we really want to write that out, right, that will be 23rd mod 9, 23rd mod 9, 23rd mod 9, multiply all together. Okay, or we can, and so that would use the product approach for modular arithmetic. So I wrote it like this so you can see how it would break down to multiple step. So I would have 23 mod 9 times 23 to the second mod 9, right? So we have a product of 23 mod 9 times 23 to the second mod 9. And since it's a product, we have to do mod 9 at the end. Then again, we would then take this and we would write it out as a product again. So I would have 23 mod 9 times 23 mod 9 times 23 mod 9 mod 9 mod 9, which gives you 8. So scientific calculator, right, would be able to give you the number right away. Okay. But if you solve it manually, this is what it should be when you write it out so it's clear. Okay, any question with 24? Okay, 25, solve 12 to the 4 mod 11. And another way that you can do this is just like doing, 12 mod 11 to the 4th power, which is 1 to the 4th power, or which is 1. Or you can use like the last approach. So alternatively, you can say 12 mod 11 times, 12 mod 11, right? And if we do this, that will be to the 3rd. And then with that, we would have, that would be mod 11 and then equal to, and then you can expand on it. Okay. And then be able to multiply that out. Just like what we did up here. Okay. For 26, you have negative 37 mod 17. So when we look at the equal to 14, right? When we look at this, we want to illustrate it. It is going to be equal to 14. So how is it equal to 14? We have negative 37 is equal to negative 3 times 17 plus 14, right? So when you have a negative value here, you would have negative a mod n is equal to n minus a mod n. Okay, so when we solve this, we would have 17, which is the mod value, right? Subtract 37 mod 17 is going to be equal to 14. Okay, any question with 26? So again, don't forget to look over the modular arithmetic. Okay. So on this one, if you know how to use the equation, that will probably be the fastest. All right, 27. Find the solution for 15 plus 29 mod 2. Okay. And we can apply this approach where we have the addition for the mod. So a plus b mod n is equal to a mod n plus b mod n mod n. So we would first take 15 and we would apply the mod 2 to it. So 15 mod 2 plus 29 mod 2, okay, for the second part, and then mod 2. And you can use your calculator to check. Well, have it mod and then plus everything together. Or you can do it manually in your head. Right? That one's easy. That should be a 1 plus another 1, right? And then, so 2 mod 2, you already know the answer. Okay, any question with 27? Okay, 28. Solve for 2 times 3 mod 7. Similar to what we did with the addition for modular, we would then do a times b mod n is equal to a mod n times b mod n, and then multiply it by mod n. So then we would say a mod 7, that's for the first part here, times, right, 3 mod 7 for the second part, and then we would mod 7 again. Okay, so a mod 7 is still going to give, 2 mod 7 is going to give you 2. 3 mod 7 is going to give you 3. So 6 mod 7 is going to give you 6. It's still going to be the... No, because so when you write it out, right, this part right here is going to be 2, right? So that's going to be equal to 2, right? And then I should put a parenthesis times 3, still mod 7. So that will be 6 mod 7. and that will be 6. Because if you take 6 divided by 7, you get 0 as a quotient with the remainder of 6. Any number that's less than the division number, it's going to be its remainder. So technically, you don't really have to write this out, right? You can operate the multiplication within, and then that will give you mod. But when we write that out, yeah, so if so the question is it 6 mod 7? Yes, but to really get the final answer, if you do 6 mod 7, you get a 6. Yeah, no problem. And this one is similar to the earlier one where we have a negative value in the front for A. So you have negative A mod n is equal to n minus A mod n, right? So you have n is 19, subtract A is 6 mod 19. So when you calculate this out, it would be 19 minus, and what's in the parentheses, 6 mod 19 is going to give you a 6. Okay, because 6 divided by 19 is 0 as a quotient with the 6 remainder. So it gives you 13. Okay. Question with 29. Okay, so for 30, we just need to use Visioneer. And for Visioneer, we just want to come up with the encrypted message given the phrase and the keywords. And keep in mind that your keyword will always extend to the length of your phrase. Okay, so here's the table. You can use the table to cross column and row. Okay. So for the plain text, we have cryptography. And for your key, it's officially, it is only encrypt. But since we have longer string for the plain text, we have to extend it to the number of characters that's equal to that string. So you have encrypt, and then you would just count it. So 2, 4, 6, 8, 10, 12. Yeah, so 2, 4, 6, 8, 10, 12. So 12 characters. So we just got to make sure that our key matches for the 12 characters. It doesn't line up perfectly, but there you go. So you start with an E and the C and the E. So we would go C and then come down to E. Go across and then come down to E. So we would get a G for the first one. So I go to C, come down to E. I get a G. Okay. And then after that, we would have the R and the N. So go across to R and then come down to N. Okay. So you should have like G, E, A, F, and I started some for you. You can fill out the rest. Okay. Any question? So on the 7th, I will have an announcement that's going to come out for your final exam password. Check the announcement, or when you look at the exam module, I will include your password information also on there. But you have to use it in order, that password, in order to access the exam. Okay. And if you have any problem or any questions or anything like that, make sure that you send me a message. I usually respond right away. So, okay. I had a couple students that had some challenges on their system accessing the exam last semester in the, not the winter, but in the fall. But other than that, the majority of the students completed it. Okay. And again, Lockdown Browser does not work on Chromebook. So if you're using a Chromebook, just keep in mind that you need a Windows or Mac OS to do that. So, yep, that is correct, David. Mac OS or Windows installation for Lockdown Browser. And if you have my class, you can keep it or you can uninstall it and install it later for the other classes. I use it for all my classes. So if you had installed it before, you can use it. So, but you simply just use the browser to access Canvas and then open the quiz, and it's going to prompt you the password. Okay. And then you enter the password, and then you take the test. It's going to give you 2 hours for 50 questions, which is a ample amount of time to solve things manually and so on. But in any case, if you have, if you require extra accommodations or anything like that, if 5 to 6 minutes is not good enough for you for one questions, make sure that you remind me. I had some stuff that been filed by the SPS, but I feel that for my time that been teaching, 5 to 6 minutes for these type of questions should be good enough. Okay, even to accommodate accessibility. So, okay, but I had one situation last semester in the fall that a student required extra time, and so I worked with the students. So I'm open to that. Okay, any question? No. So David asked if there's any questions that require handwritten work or typing in the answer. No. For this portion of the assessment in this class, because I use this to evaluate your understanding for the mathematical side. And this is the easiest way that I can accommodate that for you. Okay. So no, I will not require any kind of written answers or typing. It will be all multiple choice for the 50 questions. How I evaluated your application of the mathematical concept with programming is through your project. So, and so there are different layers in how I assess your student learning outcome from this class is through your project, your assignments, your quizzes, and your final exam. Okay, so no, you will not be required to handwrite anything. So, at university, they do a lot of handwriting stuff, especially if they have TAs to grade that. I have 5 classes and no TA. So I like to get your grades to you as fast as possible and make your life a little bit easier for the test too, right? I know that you have a lot of other exams and things to be more concerned about as well. So, all right. Any questions on final review? I will post this part of the video on YouTube and also link it to your Canvas. And so if you don't have any questions, I want to thank you for another good semester in CIS7. I love teaching this class because it's so fun. It has math and programming, and it apply a lot of like real world concept to it. And so, and I look forward to have some of you in the summer maybe for Python and or non-credit courses. In the fall, I am mainly teaching afternoon and evening courses. The majority of them are face-to-face. So I'm teaching advanced Python. If you finish the 30A, you can take the advanced Python one in the evening if you like. Um, that will be for with implementing data and database and so on. And then I'm also teaching Python with cybersecurity for it's scripting for ethical hacking mainly. And there's some stuff that's we can use for automation with that. And then I'm teaching a Network Plus class, CIS40A in the afternoon, the apprenticeship course, and of course CIS7. So if you're looking to take CIS11, I'm teaching CIS11 using LC3 in the next spring. So I'm just finishing that now. So um, and then there are other CIS courses that you can also take, Java, C++, and so on. Okay, well, I would buy you pizza, but because of COVID and virtual classroom, I will owe you a slice of pizza. So the next time you have my class, you can have 3 slices of pizza. Okay, all right, thank you. And I will stick